Hello there, welcome back to this video. Now today's title is what is a transformer? So what is a transformer? We're going to be looking at how does it work and where do we use it. Now, what we'll do now will be we're going to copy the following down, so going to be a recall on the generator effect. Okay, now if you remember, for the generator effect, so what are we doing in this case? For the generator effect, we are using movement or motion, okay, to generate. So in this case I will say to induce. So the word induce here is going to be, say, we are going to create, okay, a current slash voltage. Okay, so this is what the generator does. Using motion to induce to create a current and a voltage. Now, if you remember, what do you have in a generator? In the generator, go there. So in the generator, what do we have? So first of all, here we go. Here is a generator there. So this is a generator. Put this there. What do we have? We have the following components. We got the permanent magnet. So this here is the permanent magnets. So permanent magnets. Okay, so you got the north and the south pole. Now you end up, we have the loop here. So this is the loop. The coil of wires. In this case, we have a single coil. Okay, and then we have a circuit. So this is a circuit. Okay, and then we got two rings. We got this split. Okay, that's wrong. Okay, so we have the slip rings. Yeah, the slip rings. Now you can actually see that the slip rings commutator. Yeah. Okay, so slip ring commutator. Now, if you look carefully, the rings, they are full. Okay, so we have full rings. We got full rings. Now you got two sides of the coil. So this side here, and this side here. Let me call it A. So this side is connected to the first ring. Okay, and this side here, I'll call this B. This goes all the way and connects to this one here. Okay. Now, what are we going to do? So how can we use this setup to generate current? Let's take a look. Okay. Now, for that, I'm going to show you a different diagram, which is this one here. Okay. Now, we're going to break this down into some bullet points. Just a quick recap. Now, first of all, we have the conductor, which is the coil of wire, which is the loop of wire here. Okay. So we've got the coil of wire. Okay, so the coil of wire is moving, so the coil of wire moves. Okay, slash cuts through the magnetic field of the permanent magnets. Okay, so remember we got north to south, so we've got north to south there, so north to south. So as the coil is turning it, rotating, so you are the one making the coil rotate, so you are rotating the coils. So as you are rotating the coil is going through the wire, it's cutting through the wire. Sorry, not the coil is cutting through the magnetic field. Okay, so if you've got the magnetic field there in black, let me just do this in black. So you've got the lines here, magnetic field, from north to south. So the coil is cutting through it. So when you rotate, when you are rotating it, it cuts this way. If you remember what Pranchal did last time, and then cut down this way. Okay. Now what this does is cutting through the magnetic field. Now, remarkably, okay, this induces. Okay, the keyword we need to use is induces. So this induces and okay a potential difference. Okay, so this induces a potential difference. Okay, now it's not just any potential difference, it is an alternating potential difference, because remember what's happening is it's cutting it one way and it's cutting it the other way, and so on and so forth. Okay, so induces a potential difference, an alternating potential difference. Okay, now so if this connected to your circuit, so okay, so let's have a look. Okay, so if connected to an external circuit, okay, so this is where you get an alternating current induced. Okay, because first we end up with the potential difference, and so once the coil of wire is connected to a circuit like follows, we end up with a AC there. Okay, now let's look carefully at this here. Okay, so remember this side, let me just delete everything. This side of the coil, let's call it A, look, it's connected to this part here. Now the second side, let's call this B. You can see it goes all the way through to this side here, call it 2. Now what ends up happening is when it rotates, so when the coil rotates, so therefore A is going to stay on the first ring. So A is going to stay in the first ring. And then B, which is here, will stay on the second ring. So they stay on the second ring as well. Okay, they stay on the second ring. Now, if you remember this one, so this is what I gave you. This is the sheet I gave you last time. Okay, so therefore, so this is the AC generator. So therefore, each side of the coil is always connected to the same terminal. So if you look at the diagram here, you can see A, when it rotates, stays connected on the first ring. B stays connected on the second ring as well. Okay, so therefore it stays connected, so each side stays connected to the same terminal, and therefore the current produced is AC. You can actually see how the current is changing direction. Okay, because yes, connecting in the first direction, but you can actually see what's happening there. Okay, now for DC generators, what we have is you move the coil of wire through the magnetic field. The coil of wire is cutting through the magnetic field. This induces a voltage, just a voltage here in the wire, and then we end up getting a current being induced in the coil, in the circuit. Now remember, so here, look at that. So this one is a split ring. So this is a split ring. Only one ring and split in half. So this ensures that each side of the coil is connected to the opposite sides after each turn. So what did this mean? If you remember, let's do it this way. Let's do a diagram. So we got, this is the ring, this is the ring. Okay, this is the ring. Okay, let's take a look. We've got the ring that turns there, and this one's there, this one's there. Okay. Now, so this is the wire. This is the wire it goes. Okay. Again, I'll call this one 1. I'll call this one 2. So if the coil of wire is rotating, so this one rotates, this one rotates. So what's going to happen is you're going to end up with a point where, again, we're going to look at it in 3 stages. In 3 stages, yeah. So when this turns, so number 1 will end up here, number 2, so move from here, and then number 2 will end up here. Okay, you can actually see this point. Okay, they are not connected. So here they're not connected, not connected. So there's no current flows, no current, because it's disconnected from the circuit. Yeah. And here, because what happens, since they're already moving, so this will keep moving it to this side. So therefore 1 will be here, and then 2 will be here. Okay, you can actually see what happened. So each side of the coil is connected to the opposite side. So now 1, so this is 1 was here, and then 1 is there. Okay, you can actually see it's connected to the opposite side. So 2 was here, and what happened? 2 was there. Okay, so what happened is the side of the coil swapped, yeah. But since there's a gap there, it gets disconnected. So this resets the current. So this resets the current to go up. So for example, if the current, let me see if the current, let me just delete this one, delete the purple one, purple one, purple one, purple one, purple one. If the current was going, okay, so we are wait, okay, so we are producing current. Remember, we are generating current. So this is generator. So if current is coming in, yeah, anyway, so if current is, let's say, being produced in the coil, and let's say the current goes in. Oh my God, these. If current, wait, what? Okay, that's weird. Okay, let me just pause this. Right, so if current get created and the current goes through this terminal here and then to go out and then go through the circuit, come back in here again. So what end up happening is here. So remember, the current is going out this way and in this way. So here, when it gets disconnected, there's no current. Therefore, there's nothing. There's nothing. And then when the current resets again, means once the current resets again, so current was coming out where? On the right. So the current stays coming out on the right, and then stays going in to the left hand side because of this gap here, because it gets resets. Okay, we're going to just trying to keep it simple as possible. Okay, now today we're going to ready to look at what we are here for. Would be again to make sure that you got this so far in your notes. We're going to be looking at transformers. Okay, nice one. Now transformers, what do they do? Now transformers, they are a device that can change the size slash magnitude well, what am I doing? It is a device that can change the size, magnitude of an alternating potential difference. Means alternating. Now, what does alternating mean? Means changing direction changes. Okay, so if it's going to the right, the direction changes, goes to the left. Okay, that's what I mean. So it is a device that is able to change the size of the alternating potential difference. Again, what is potential difference? Potential difference is just voltage. Okay, now how does this work? Now let's take a look at a diagram. So we got a transformer is made up of the following objects. So we have normally we have a rectangular iron core. So this here is an iron core. So write it down, iron core. Okay. Now we talk about why we use an iron core in a bit. Now we have an iron core there. Now what we have is on one side we have a coil of wire that is wrapped around this point here. Here we go. 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 So now what we do, so we got 1, 2, 3, 4, 5, 6, 7 turns. 7 turns. Now what I'll call this, so this is the first one. We'll call this primary number of turns. Or primary coil. Yeah, primary number of turns. Okay. So this will be my primary coil there. Okay. Now, then what we have is on the other side, we have a second set of wire. We're going to loop it around as well. So we've got the wire here, we wrap it around. Okay, let's check. Here we go. 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 Now likewise, we're going to call this these sets of wire, just I think you guessed it, secondary number of turns. Okay. So this will be my secondary coil. Primary coil, secondary coil. Yeah. Okay. Now, what I'll do is I'll give it the letter to make my life easy. So I'll call this one N for number of turns, P for primary. Okay, put this in brackets. And this one I'll call this second. I'll go again N, capital N for number, and I'll call it S for secondary. Okay, how we go? So iron core, we got wires wrapped on the left, wires wrapped on the right. We give him some names there. Now for this to work, what we're going to do is we're going to supply it with an alternating voltage. We're going to look at why do we need an alternating voltage. We're going to place an alternating voltage there. Okay, and then I'll call this primary alternating voltage. Okay, so primary alternating voltage, and I'll call this capital V for voltage, small p for primary. Okay, now primary voltage. So since this is a circuit, we're going to follow. Is this going to be followed by a current? Now, since we're using an alternating voltage, the current that we get will be an alternating current, so an AC current for short. Okay. Now, here's the first question. Here's the first question we want to answer. Now, here are the questions that we want to answer. Now, what flows in the primary coil? So we know. What is this? What does foil? What does this current mean? So this is an AC current. So AC current flows in the wire. Now this is done. Now what is generated around the wire? Now this here is what we've learned in the motor effect. So we've got wire, we've got current in the wire. What is generated around the wire? So we've got the magnetic field that's been generated around the wire. So we have a magnetic field has been created. Now let's draw the magnetic field because we've got the wire. Remember, we've got the current go through the wire. So this current, and then current go back. So we've got the magnetic field. Now let me draw the magnetic field. So here we go. So red wire. It goes around, come back here again. Okay, goes there, come back. Oops, magnetic field. Okay, so this is the magnetic field. Okay. That's how the magnetic field looks like. It's a loop. Okay. Now, next question is what is special about it? What is special about this magnetic field? So we've got a magnetic field there. Okay. Now, this magnetic field, okay, changes direction. Now, why did this change? Why did the magnetic field change direction? So here, the magnetic field was pointing down. Now it's going to change direction. Means it's going to be pointing up, and then later it's going to change direction, pointing down, change direction, pointing up, change direction, and so on and so forth. Now, why? The question is why does it change its direction? Now, it changed direction because we're using an alternating voltage. Sorry, an alternating current. Okay. Now remember, the motor effect. What we have, we got current in wire. What did this do? Okay, this creates magnetic field. Around it. Okay, so this is pretty much in a way and then we could have the magnets, blah 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 blah. So this is like the motor effect without all these things. So this is just like electromagnetic induction, I would say. Let me just call it as this. Electromagnetic induction. So here what we have current, okay, in the wire, and this induces or creates, the word induces creates a magnetic field. Okay, and since we're using an alternating current, we end up with a magnetic field that is also alternating magnetic field. Okay, Now here's the beautiful point. What's special about it? It changes direction. Changes direction. Okay. Now, where does it go? Where does it go? And how does it get there? Now, here is the beautiful stuff. Now, the magnetic field that has been created. Okay, so it goes down, 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 down. Now, instead of leaving the core, what it does, the ion core will channel it. So here, get channel, you get channel, and then it's gonna go through the wire, cut, 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 cut through the wire, cut through the wire, cut through the wire, cut through the wire, and then come back again to this one. And let's say we have another one there as well. Go through the ion core, channel through, cut, 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 cut. Here we go. Okay, here we go. All right. So now what it does. So now we got the ion core. So ion core easily magnetized and demagnetized as well. Can easily be magnetized. So what it does, it channel the alternating magnetic field to the secondary coils. Okay. Now we want to know what is going on here now. What is going on here now? Here, what's going on here? Okay. So here we've got the alternating magnetic field cuts through coil, and this, what did this do? This going to induce, this induces alternating voltage, and then this gets us AC. So therefore, because remember, the magnetic field changed direction, so it means the one is cutting this way. Wait, let me just use a different color pen there. Let me use red. So it's cutting it this way, and later on it's going to reverse and cut it down. So cut up, cut down. So it's cutting, cutting, cutting. This will generate a voltage, which is I'll call this voltage Vs. Okay, and then we're going to get an AC there as well. Okay, so this is how it works. So this is how a transformer works in this case. Now, a question can come up as the 6-marker questions. Talk about transformers. Why do we use it? This is to change the size of the potential difference in this case. Now, you see, we put in the voltage here. So here, for example, if I put in, let's say, 10 volts. Now here, I can get 10 volts, or I can get something else. You know, I can get, I don't know, I can get 10,000 volts. Okay, we're going to find this out as well. I can get, I don't know, I can get 5 volts. Okay, so it changes it. Okay, now make sure that you got everything so far in your book. Okay, if you are lagging in terms of notes, so this is the point we got. Okay, so this is the point we got. So when an alternating voltage potential difference passes through the primary coil, an alternating current is generated in the iron core. We can see that the one in red. The magnetic field line passes through the secondary coil. Since it is changing direction, since the magnetic field changes direction, this induces a potential difference. Okay, so make sure that you got everything so far in this case. Okay, nice, very good. Now, there are two types. Of transformer. The first one, we call this a step-up transformer. Okay. Now, a step-up transformer, just like the word says, is going to step up the voltage, going to increase the voltage. Now, how does it look like? It's going to look like the following. So we got the rectangular shape. Okay. Now we got the primary coils. Okay, a step up. 1, 2, 3, 4. So here I'll call this one, let's say, a primary coil. So let me call it primary coil. Okay, and then we're going to have the secondary coil. Okay, so secondary coil. Okay, so here we go. Now, how do we know if this is a step up, a step down? Now, step up, you can see that the number of turns, so I'll call this NS, the number of turns will be much, much higher. And the primary turns, the primary NP will be lower. Okay, so what this do, this will make, so what's going to happen, the voltage that we put in, the voltage primary we put in, and what we're going to see is we're going to get a voltage which is secondary, which is going to be much, much higher, just because the fact is just the fact that we got more wires, more coil of wires on one side. Okay, so this is what a step up transformer do. So potential difference across the secondary coil, which is here, is greater than the potential difference across the primary coils, because we have more number of turns. So there's more number of turns on this side compared to the other one. So therefore, we're going to step up the voltage. So if you put, for example, I don't know, let's say we put in, let's say 10 volts here. Right, let's say 5 volts. We put 5 volts here. We can get 13 volts here. So this is stepping up. We are increasing the voltage. Okay. Now the second type, I think you guys guessed it already. The second type is going to be called a step down transformer. So the word down tells you what it's doing, and again we want to know how it looks like. We're going to have our rectangular block. Okay, rectangular block. We got the primary turns. Okay, and then we're going to have the secondary turn, which is here. There we go. So again, primary turns, a primary coil. I'll call this NP, of course. We're going to have the secondary coil. I'll call this NS in this case. Now, what happened is, look, the wire's number of turns is less. So what we have is the number of turns here is less compared to the other one. Okay, so it's less. So therefore, what's going to happen is the voltage that we get from this, so VS, so voltage secondary is going to be lower. Okay, so that's how we can get it. There we go. You can actually see. Now, think of it. Where do we use this one? Now, this is used normally, so step down transformer, so used normally in your adapters. Because what happens is when you charge your phone, the voltage coming from the main is 230. And maybe your phone needs less voltage. Maybe your phone needs, I don't know, let's say 12 volts or 30 volts. So they need to step it down. So your adapter and your charger need to step it down so that it's safer for your phone to use. Okay. Now, if you look back, so the voltage that comes from the power station could be at a much, much higher voltage, and so therefore we need to step down. Now, in your notes, you should have. I'll show you guys you will see a diagram on your worksheet about where we use a step down transformer from the power station in this case. Okay. Now, so this now you can actually see the link between the number of turns, the voltage, and so on. Now what we're going to do is we're going to link them together. So there's an equation that links the number of turns and the coil of wires. So the equation is the following. So we've got the primary voltage that we put in, okay, divided by the secondary voltage. So the ratio of that, this will equal to the primary number of turns divided by the secondary number of turns. ohms. Now, let's simplify this even further. So therefore, remember, with a few words we call this now. Primary voltage, we call this Vs divided by secondary voltage. Okay, so primary turns, we call this Np divided by secondary voltage, we call this V. Oh, sorry, that's bad. That's my mistake. So this is Vs, this is Vs, this is Ns, and this is going to be Np. Here we go. So therefore, now we can work out what's missing. Okay, now let's do one example. Let's do one example here. Example. Let's say I have a transformer. Okay, let's say the coil of wires is there. Then let's say here we got coil of wires. Okay, here we go. Now let's say the primary, let's say the input is 230 volts. So input here, so this is AC. And let's say this one here is, I don't know, 40 volts. Okay, and let's say I have number of turns is 100 turns. And the question says, how many turns do we need here? Okay, now first of all, what kind of circuit this is? So this here is a step up. Now, how do we want to step up? Look, we are putting in 240, and look, we get 480 out. So this is a step up transformer. Okay, so therefore, what do we expect? We expect turns, the number of turns to be higher because we're getting more voltage. Okay, so therefore, this tells you already what your answer should be. So your answer should be more than 100. Now let's use the equation now. So we got Vp over Vs is equal to Np over Ns. Now the question is, we want to work out the Ns. So what I'll do is I'll rearrange the equation. So I have Vp multiplied by Vs is equal to Np divided by Vs. I just need Ns, so Ns is equal to Vp multiplied by Vs, and then divided by Vp in this case. So Vs is going to be, so this is going to be, Np is going to be 100 multiplied by Vs, which is 4. This divided by Vp, which is this one here, and the answer would be 200. So therefore, the answer would be 200 turns. So therefore, I need 200 turns, and it makes sense because this is what I expect to happen. Okay, so is this good so far? Alright, so this is your work example. Make sure you copy this down as well. Okay, let me just go back. The equation, copy this down. Okay, so the whole thing here. We need to know that. And this definition, copy down, of course. Okay, so step up. This down as well. Okay, so we're done. We talk about this one as well. You can also copy this down as well. Okay, so once you're ready, you can move on to do your worksheet in this case. Yeah, you can crack onto the worksheet. Okay, and then we're going to be talking about the other one as well. You know what? Let's talk about this one as well. So this way you can do all the worksheet in one go. Okay. Now, transformers, they are the only device I can think of. Okay, so they're near 100% efficient. Okay. Now, what does this mean if they're near 100% efficient? So this means that the power that you input in is equal to the power that you output. Okay. So this means what? What does this mean? Now, what is the equation for power? The equation for power is, so P is equal to IV. Okay, so the power that we put in, so this is the primary one. Okay, and the power that we output, this is the secondary one. So what does this mean? This means that if we have power for primary, so P for primary equal to power for secondary. So therefore, I have I multiplied by V equals to I multiplied by V. Now, This will be primary, so IP, VP, primary. This will be IS, VS in this case. So I end up with this equation there. Okay. So because they are the same. Okay. Now, check this one out. I think I can talk to you about this one as well. Okay. Okay. Now, check this one out. Okay, let me see what can. So how can we do this? Now, what we're going to do is we're going to rearrange. So, rearrange for VS. Okay, let's do this one. So therefore, what we have is we have IP divided by S. Okay. Now, check this one out. So for step-up transformer. So for a step-up transformer, VS is going up. Okay. Okay. Now, so the equation is VS equal to IP. This. Okay. Now, if VS goes up, what happens to current in the secondary coil? The current in the secondary coil goes down. Okay, so this tells us that VS and IS are inversely proportional. Now, what did this do? By increasing the voltage, by stepping up the voltage, this allows less current. Okay, so this, okay, by stepping up the voltage, this allows less current induced. Okay, this allows less current. Okay, now what we're going to do in the next lesson, we're going to find out why do we need less current? Why is there a need for less current? Why is there a need for less current? Now, the hint I will give you for today, the hint will be national grid. Okay, so this is the hint. That's it. Now, you should have been given some worksheet. I would like you guys to crack on to the worksheet in this case. Okay.